So, hello everyone, I am Param Shah, and today I am presenting my 3D model on AI accelerators and modern CPU extension, and my ID is 24C093. So this model demonstrates how modern computer systems are designed to efficiently handle artificial intelligence workloads. So in today's world, artificial intelligence is used in many applications such as image recognition, voice assistance, recommendation system, and autonomous vehicles. So this application requires processing of large amounts of data and complex mathematical computations. So traditional computing systems using only CPUs are not efficient enough to handle such workloads. So this is why modern systems use advanced techniques like CPU extensions and specialized AI accelerators. So now at the center of this model we have the CPU or central processing unit. So the CPU is responsible for the executing instructions and controlling all operations in a computer system. So it follows a sequential processing model, meaning it processes only one instruction at a time. So now if we see the animation, so this approach is suitable for general purpose tasks like running programs, handling input, output, and system control. So however, when it comes to AI workloads, which involves processing large data sets and performing repetitive mathematical operations, this sequential approach becomes inefficient. So now we will move to AVX block or vector processing unit. So to overcome this limitation of the CPU, modern CPUs include extensions such as AVX, which stands for Advanced Vector Extensions. AVX is based on the concept of SIMD, which means Simple Instruction Multiple Data. So in SIMD, a single instruction is applied to multiple data points immediately, simultaneously. For example, instead of adding numbers one by one, the CPU can process multiple additions at the same time. This improves performance significantly for the tasks like image processing, video processing, and scientific computations. However, even with SIMD, CPUs are still general purpose processors and are not fully optimized for AI workloads. So now we will move over to main part, which is AI accelerator. So to handle AI workloads more efficiently, specialized hardware called AI accelerators are used. Examples include TPUs, which are tensor processing units, and NPUs, which are neural processing units. These accelerators are specifically designed to perform operations used in artificial intelligence, especially matrix multiplication. So in neural networks, data is processed in the form of matrices, and large number of matrix multiplication are required. So AI accelerators are optimized to perform these operations very quickly and efficiently in comparison to CPU and AVX. So unlike CPUs which are designed for flexibility, AI accelerators focus only on specific tasks, which make them faster and more energy efficient. So now if you see a data flow and architecture, so the connections shown in this model represent the flow of data between different components. Depending on the type of task, the data is sent to the most suitable processing unit. For example, general tasks are handled by the CPU, vector operations are handled by AVX, and AI computations like image processing, video processing is handled by AI accelerators. So this division of work improves overall system performance. So now if we see real world examples of this, so this architecture is widely used in real world systems. For example, smartphones use NPUs for face recognition and voice assistant. Cloud computing platforms use TPUs for training deep learning models, and autonomous vehicles use AI accelerators to process sensory data in real time. So now if we see comparison between, we will summarize the comparison between all three. And in summary, CPU provides flexibility and handles general tasks. AVX improves performance using parallel data processing, and AI accelerators provide optimized and high-speed computation for AI tasks. So now, what is the future scope of this? So if we see that in the future, AI accelerators will become more powerful and widely used, enabling faster and more efficient AI applications. So now in conclusion, I would like to say that the combination of CPU, modern extensions and AI accelerators represent the evolution of computing systems to meet the demands of artificial intelligence.